Hello everyone, myself Sravanthi, working as an assistant professor in Department of Cybersecurity and Data Science in MLR Institute of Technology. Our subject is Automata and Compiler Design. In that subject, the first topic is the basic concepts of Finite Automata. To learn the Automata Compiler Design, we need to know what are the basic concepts, what are the terminologies we are going to use in a Finite Automata. So, in that, we are going to discuss what is alphabet, what is a string, what is a language, what are the operations that takes place in a string, and what are the operations that takes place in language. So these are the three concepts we are going to discuss here. So what is an alphabet? An alphabet is nothing but it is a finite non-empty set of symbols. Here we'll be having in alphabet, we are going to represent it with a sigma. Sigma is used to represent alphabet. It consists of set of symbols. The set of symbols can be either alphabets or digits or letters, anything. Either it can be punctuations, anything can be written as a alphabet. That is represented with using sigma. For example, sigma equal to 0, 1. Here 0, 1 are the binary alphabets. And the next one we are having is sigma equal to A, B, C, Z. So these are nothing but lowercase letters. Anything can be represented in an alphabet. Either it can be a digits or letters or punctuations, anything. So those all comes under alphabet. So these are nothing but set of ASCII characters. The alphabet is represented with sigma. So this is what alphabet. So the next one we are having is string. So what is a string? So till now we have learned what is the alphabet. Alphabet is nothing but it is represented with sigma. It consists of finite set of symbols. So now string is nothing but it is a collection of symbols. String is nothing but it's a collection of symbols from the alphabet. We are going to write alphabet is nothing but 0, 1. These are nothing but digits. So it is nothing but sigma is nothing but it is collection of symbols. 0, 1 are the symbols. Now coming to the string. So what is a string? It's a collection of symbols from the alphabet. From these alphabet, we are going to write the strings. So what are the strings I can write from these? Is nothing but 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, so on. All these are nothing but strings. Each one is nothing but we are going to call it as a string. So these strings are written from this alphabet. So alphabet is represented with sigma and string is represented with W. String is represented with W. So either I can represent string with W or S. W or S. So this is what string. See here one example we have written sigma equal to A, B. So various strings I can generate from these sigma equal to A, B. A, B are nothing but the alphabets. From these alphabets I can write any type of strings. Any type of strings that starts with either A or B. It's a combination of A and B. So this is what string. So the next is there are different operations are there under string. So first one is the basic thing we need to learn is empty string. So what is empty string? Empty string is nothing but nothing is there. 0 symbols. So nothing is represented. So that is represented using epsilon. Empty string is represented with epsilon. So here epsilon is nothing but nothing is there. It represents that nothing is present in a string. So it can be represented with using alphabet is nothing but sigma power 0. Sigma power 0 is nothing but 0 represents length of the string. Set of strings of length 0 over sigma. So I can write sigma power 0 is equal to nothing but epsilon. Epsilon is nothing but empty string. No symbols are present. Nothing but 0 symbols are present. So length of epsilon is nothing but 0. But how many number of strings are there? Only one string is present. So here we need to point out is the total strings that are present here is 1 and the length of the string is nothing but 0 as it is a empty string. The next one is length of string. So the length of the string, how we represent the length of the string? String is represented with the word symbol W and coming to the length of the string is represented with mod W. mod W is used to represent the length of the string. So what it represents is length of the string is nothing but the number of symbols that are present in the string. So for example, if I take W is equal to 0, 1, 1, 0. So how many number of symbols that are present is my length of the string. For example, see here, how many, what is the length? 1, 2, 3, 4. So the length of this string is 4. The length of this string is 4. Same here, which we have written, W equal to 0, 1, 0. The number of strings is nothing but 3. See here, 0 is 1, 1, 1. So total number of length is 3. Number of symbols present here is 3. So for example, AB. AB is nothing but what? Number of symbols are 2. A is 1 symbol, B is 1 symbol. So that is nothing but there is 2. B is nothing but only 1 is there, 1 symbol. So that is 1. Epsilon. Epsilon is nothing but empty string. 0 symbols are present. So that is why we are representing it with 0. The next we are having is substring. So what is substring? We are having a string. From that string, we are going to have some part of that we are going to take. That is nothing but substring. For example, see here, W equal to A, B, C, D is a string. I am having the substrings that are present from the string W is nothing but I am having a string W is equal to A, B, C, D. So what are the substrings that are present? A is one substring, B is one substring, C is one substring, D is one substring, AB is one substring, BC is one substring, CD is one substring, ABC is one substring, BCD is one substring, and ABCD are the other substrings. So these are the substrings that are present from a string W. W equal to ABCD is my string. From this string, we are going to write the substrings. So I can write the substring, but I cannot write the substrings like AC, AD. These are not the substrings of the string ABCD. Why? Because I am having A is one substring, B is CD. It is a continuous, but AC is not there here. So that is why we cannot write. These are not the substrings. AC, AD, BD, ABD. These are not the substrings. Okay. The next one we are having is prefix of a string, which we already know. What is a prefix? Prefix is nothing but the leading symbols we can call, or starting symbols we can call. Starting symbol of a string, we are going to call it as a prefix of a string. We can also call that is prefix of a string is nothing but leading symbols, and we are also going to call it as a starting of a string. So the number of prefixes for a string of length n is will be n plus 1. For example, I am having W equal to ABC is my string. ABC is my string. So what is the length of the string? Is equal to 3. And the number of prefixes I can write from this string is n plus 1. Nothing but 3 plus 1. 4 prefixes I can write. So what are the 4 prefixes we can write is from these ABC is epsilon, A, AB, ABC. So see here 1, 2, 3, 4. So I have written 4 prefixes from the string ABC. So leading symbols, nothing but we are going to take the starting symbols. A, B, C, individual, nothing but A, B, A, B, C. Okay. So this is nothing but prefix of a string. The next one is suffix of a string. So the suffix of a string is nothing but, just now we have discussed that prefix of a string. Prefix of a string is nothing but the starting symbol. Nothing but leading symbols we are going to tell. So now coming to the suffix of a string is nothing but trailing symbols. Trailing symbols are nothing but we are going to call it as a ending of a string. Ending of a string. Any number of trailing symbols of that string. Similarly, here also the length of the string is ABC. What is string is W equal to ABC. The length of the string is nothing but n plus 1. Nothing but 4. And how many prefixes I can write? 4 prefixes for this string. So same thing. Epsilon. Just now we have written for prefixes starting onwards. Coming to suffix, we are going to write from last. Nothing but trailing symbols. Ending of a string we are going to write. So nothing but C, B, C and A, B, C. So these are the 4 we are going to get. 4 suffixes we are going to get from the string W equal to A, B, C. So the next one we are having is powers of an alphabet. So what is powers of an alphabet? Alphabet is represented with sigma. Alphabet is represented with sigma. So it is nothing but the set of all strings of a certain length from the alphabet by using an exponential notation. So nothing but sigma is nothing but it is represented as an alphabet. We are having the length of the string that is represented by using exponential notation. Nothing but alphabet is represented with sigma and we are going to write some exponential notation that represents, that is the length of the alphabet. So nothing but sigma power k. K is nothing but it is showing me the length of the string over alphabet sigma. See here, sigma power k is nothing but set of strings of length k from sigma. So here let sigma equal to 0, 1. So here I am having a length of the string as sigma equal to 0, 1, 0, 1. Here sigma power 0 is nothing but epsilon, which just now we have discussed. This is nothing but empty string we have discussed. Sigma power 0 is nothing but the length of the string is 0. Length of the string is 0 is nothing but nothing is there here. So nothing but it is represented with epsilon, empty string. So sigma power 1. Sigma power 1 is nothing but the length of the string is of 1. So the length of the string is 1. 0 is 1 length, 1 is 1 length. So that we are going to write here sigma power 1. Next coming to sigma power 2. Sigma power 2 is nothing but 2 length string. The length is nothing but it is showing me 2 is nothing but sigma power 2. 2 is representing me the length of the string. So the each string should be having the length as 2. See here, my alphabet, what I am having sigma equal to 0, 1. So the length is 2. So nothing but 0, 0 I can write, 0, 1 I can write, 1, 0 I can write, 1, 1 I can write. But I cannot write 1, 1, 1. Why? Because this length of this string is 3. So, but here what we are going to show, sigma power 2 is nothing but the length of the string is only 2. We are not going to show here the length of the string is 3. So, this is invalid. We cannot write 3 length string. We can write only 2 length strings. So, similarly, we can write sigma power 3, sigma power 4, sigma power 5, so on. What we need, that is nothing but powers of alphabet. So, here the set of all strings, all these strings which we have done here, sigma power 0, sigma power 1, sigma power 2, all these are nothing but it can be denoted by sigma power star, sigma power star. So, this is nothing but we are going to call it as Kleene closure, that we will learn in your next topic. So, Kleene closure. So, Kleene closure. So, it is nothing but the set of all strings over an alphabet that is denoted by sigma power star, sigma power star. It is nothing but sigma power star is nothing but it's a combination of sigma power 0 union sigma power 1 union sigma power 2 union sigma power 3 union sigma power n, so on. So, how many we have? That many we can write it. So, it is nothing but sigma power star. So, once again I am repeating, sigma power star is nothing but here I am going to have 0 more occurrences. 0 or more occurrences is nothing but I have written sigma power 0. 0 also we are going to represent in sigma power star. Okay, so that is nothing but sigma power star. Coming to sigma power plus, plus closure. So, plus is nothing but here we are going to have non-empty strings. Non-empty strings are nothing but one or more occurrences. One or more occurrences. We can observe here. Here in the sigma power star, I have 0. But coming to sigma plus, I am having 1. So, we are going to delete sigma power 0 in sigma power plus. So, that is why we are going to tell it as one or more occurrences. Here we have told that 0 or more occurrences. Nothing but I am writing sigma power 0. But coming to here sigma power plus, I am writing sigma power 1. So, nothing but sigma power star we are going to call it as Kleene closure, and sigma plus is nothing but we are going to call it as positive closure. So, plus represents positive and star we are going to call it as closure. So, this is nothing but powers of an alphabet. So, what is powers of an alphabet? Alphabet is represented with sigma. Power is nothing but we are going to write some power for that. That power is representing me the length of the string, length of the alphabet, and how much length I am going to use in my alphabet. So, the next one we are going to have is concatenation of strings. So, what is concatenation? So, concatenation is nothing but appending the second string at the end of first string. We are going to append, there are 2 strings and we are going to append the second string at the end of the first string. So, that is nothing but concatenation of strings. If X and Y are strings, then XY represents their concatenation. So nothing but if I'm having X equal to some ABC and Y equal to DE. So X is one string and Y is second string. So what we have told, concatenation of string is nothing but appending the second string at the end of first string. We are going to append the second string at the end of first string. So that is nothing but concatenation of strings. It can be represented as XY or X dot Y. So what we will be getting, ABC is my first string and I am going to append second string at the end of first string. This is my first string and this is my second string. I am going to append at the end of my first string. So that is nothing but concatenation of strings. So the next one is Kleene closure. Kleene closure. In powers of alphabet, we have discussed some sigma power star. Okay, so star is nothing but it is going to tell me the Kleene closure. So what is set of all possible strings including epsilon over an alphabet. Including epsilon, we are going to write. It is nothing but 0 or more occurrences. 0 or more occurrences. 0 is nothing but including epsilon. 0 is nothing but the length of the string is 0. Length of the string is 0 is nothing but we are going to represent it with epsilon. So the remaining more occurrences. We have written sigma power 0 union sigma power 1 union sigma power 2. So that represents set of all strings, possible strings including epsilon. Epsilon is also included. So that is nothing but sigma power 0, sigma power 1, sigma power 2, so on sigma power n. So it is denoted by star, Kleene star. It is represented with star. We are going to call it as Kleene closure or Kleene star. Okay, so and it is denoted by sigma power star. Sigma is nothing but alphabet, star is nothing but Kleene star or Kleene closure. For example, see here, let sigma equal to a comma b. Let sigma equal to a comma b. So then sigma star is equal to sigma power 0 union sigma power 1 union sigma power 2 union sigma power 3, so on sigma power n. It is nothing but union of all lengths of the strings. 0 represents length of the string is 0. 1 represents length of the string 1. I am going to write here string length 1. Sigma power 2 is nothing but length of the string is 2. 2 length strings we are writing. Here sigma power 3 is nothing but 3 length strings. N is nothing but n length strings we are going to write. So here sigma power 0 is nothing but epsilon. Sigma power 1 is nothing but 1 length strings. My alphabet I am having is a comma b. So a is 1 length, b is 1 length. Next I am having sigma power 2. Sigma power 2 is nothing but 2 length strings we are going to write. So each string is of length 2. So a is 2 length, ab is 2 length, ba is 2 length, bb is 2 length. For example, sigma power length 3. 3 is nothing but what I am going to get 3 length strings over an alphabet a comma b. A, A, B, 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 A, B, 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 A, so on. How many I will be getting here? 2 power 3. Nothing but 8 I will be getting. How we are writing 2 power 3? Here my alphabets are of 2 I am having. A is 1 and B is 1. So based on that 2 and the length of the string is 3. So I am getting 8. So here I will be getting 8 for sigma power 3. So and these are nothing but all possible strings. If I combine all these, I am going to get this one. So nothing but sigma A, B, A, B, B, so on. So this is nothing but Kleene closure. Next, positive closure. So positive closure is nothing but set of all strings excluding epsilon over an alphabet. Before that, positive Kleene closure. In that Kleene closure, we have discussed it as a including epsilon. Epsilon is included in Kleene closure. But coming to positive closure, excluding epsilon. Here nothing but one or more occurrences. But coming to here, 0 or more occurrences. So that is the main difference for clean closure and positive closure. Here the plus represents positive closure, star represents clean closure, and coming to here sigma plus is nothing but positive closure. We are excluding epsilon. But coming to here in clean closure, we are including epsilon. We are including epsilon. See here in the example, let sigma equal to a comma b. So sigma plus is nothing but sigma power 1 union sigma power 2 union sigma power 3, so on sigma power n. So the same thing can be written as sigma power star minus epsilon. Sigma power star minus epsilon. See here, sigma power star is nothing but I am going to have sigma power 0 union sigma power 1 union sigma power 2, so on. Sigma power 2 union, so on. Coming to sigma power plus, I am going to have sigma power 1 union sigma power 2 union sigma power 3, so on. So the same thing I can write it as sigma power plus is equal to sigma power star minus epsilon. So epsilon is nothing but sigma power 0. So these and these both are pointing to same. Okay. So sigma power plus is nothing but a comma b union a b b a b b a, so on. So this is nothing but sigma power 1 and this is nothing but sigma power 2. This is nothing but positive closure. Thank you.